so good. So there maybe we can use those things. So this is basically the overall my topic. These are some of the papers. As I told you, it started only 2009, but huge work is going on in all over the world. Many aspects, but architecture is basically a very, very important part. If I want to really utilize the potential of this that means this method, we have to incorporate many new ideas, many new algorithms to this to get better accuracy, better stability, and better confidence before using this for solving fluid flow problems. Thank you. Yes.
Sir, you just said that we can solve the non-linear PDs also with using the pin. I work in hyperbolic PD, so wherever we have the weak solutions like discontinuous solution arises like shock or data shock, so capturing it numerically with existing numerical methods like semi-discrete, central of the scheme and all, it's very difficult. There are a lot of decimation. So can we use pins to get the better results? Like
look, people are working. Actually, there are a few papers came recently for hyperbolic equations. As you told, the problem there is more on numerical decimation, numerical dispersion, right? Yes. And also oscillation in some way, stability is issue.
Yes.
So yes, in my point of view, this could be a good alternative. But as I told you, you have to define or refine your architecture to capture that. Still, we have not used that, but there are some method already they are trying to use that to capture this waviness of the thing. As I told you, still method is not good for this wave capturing wave or capturing shock waves, basically shock waves. So we have to modify the method. Basically, look, everything depends on mathematical function. That is we are saying activation function or loss function. Loss function is still in our hand. Activation function is the most important part. That is the nucleus of the neuron, or you can say that the artificial neural network. And that is mathematics can do lot of things. So if we can come up with a very nice function which will be very effective to capture those things, then people will be love to use those architecture. Only thing mathematics can help these things. That is my personal view. So the thing nothing but the activation function and pre-activation functions. And they are nothing but the functions mathematics.
But here, when you are, I'm just continuing our question. You are going to the turbulent region, keeping the Reynolds number high. But at the same time, you are validating your result with subdiffusion. Just four slides back, you have shown the subdiffusion. So how you are fluctuating from turbulent zone where the super diffusion occurs,
so if you
now
see,
to the subdiffusion.
if you see that, this is the basic. You can say that the very very early stage of the flow. Not like if you go for continue for a long time, turbulence effect will come. But I have done it up to 9,000. If you see our Computational Journal of Computational Physics paper, where we have used our numerical methods, up to 9,000 you can easily capture that for first one. After that, nonlinearity or turbulence comes into picture, and it is available in the experimental point of view also. Experimental result available. If you go for the Katonchi and P.G.D.A.V and Katonchi paper in 1980, they have experimental level up to 9,000. So initial stage, no problem, linear. After some time, it goes to turbulence. And we have captured very efficiently using our numerical method. That is our, as I told you, higher order compact scheme.
Sir, I have a submission to you.
Yeah.
Just as a senior researcher.
Yeah, sure.
Your work is very good.
Mm-hmm.
That's why I have interviewed.
Yeah, right, please.
So, where you have taken the long tail, there you can use, just you can see by keeping normal 0 sigma root t. That means if you keep it in stochastic Gaussian way. Yeah.
Actually, what we have done, that's why that is a good suggestion. What we are using convective boundary condition, because that is the problem. If you see our previous result, we have a lot of things. If you go using our simple boundary condition, you can give a stretching of that. It will come.
That's why
exactly.
Sigma root.
Exactly. So basically, that is basically what we have seen that the best result can come if I use convective boundary condition. That is there in our paper. So convectiveness is captured that. You can see totally different result. But if you use simple boundary condition, it is not going to capture that. So you are right. So basically, as I told you, this 9,000, it is basically what we have.
At the same time, you will get a domain minus infinity plus infinity. No
Yes.
problem.
Yeah.
Whether if you use value function or tan parabolic function, you are getting the.
So what I am saying that for this 9,000 3,900 that paper actually that calculation we have just done because reviewer told us to go for the higher thing to capture that. Otherwise, this is a new another work we are doing. there we are going to capture the turbulence modeling. This is just okay. The reviewer what is called suggestion. We have just keep it in our paper.
Good, very good.
Yeah.
Okay, so do you have any means, order of convergence or convergence finding in your result?
Yeah. So basically, as I told you that that is basically very few. Okay, that means theorems or few analyses are available for this type of problems. One is called, as I told you, universal approximation theorem, stability concept, discrete stability analysis. These are there, and we have studied those things. And here we have taken 10 to the -6 for our accuracy point of view for our tolerance limit.
Talking about order, means what is
Order actually for this type of problems it is very difficult to capture. Okay, I have not done it, and it is not okay. I have not seen any, because data, when you are putting data, problems are there. So that's why there is two things. One, your data may be correct, and maybe you have some noise. So both the cases I have
any idea to means, find get algorithm to find suitable activation function? Like means
no,
we
there
have
is no
chosen random.
trial and error.
Yeah.
Your concept of mathematics is very important.
Suppose the model is given, so if there is any algorithm who can tell you about for this model you can.
No, that's not telling. Basically, as I told you, activism function what it does. It basically you have some weights. You are basically making it non-linear. So non-linear, capturing non-linearity is required your activism function.
And at the same time, range should be finite.
Exactly. Many things are there. So a good
Domain may
mathematics.
be infinite, but
Right.
range should be finite.
True, exactly. Because computational without so that's what I'm telling. As a mathematician, this is our responsibility to make better functions, and it is good to us because if you are doing in applied mathematics, also you have some good knowledge in mathematics.
But what he has told you, sir, Professor Vinit,
Yes, yeah.
is very good in computation.
I know that. I know. That's the testing because that is a good thing for us.
Analysis, but at the same time, I am seeing it is fluctuating from subdivision to superdivision to subdivision.
Exactly. So that is the problem. Capturing this is not there. So this is the first model we have proposed it, but I told you lot of refinement, lot of advancement is possible, and we are working on that. Because I personally feel that mathematician could be because most people see that I have seen the group of people in Japan actually see that some of them came in that Goa things they are working. There is a very good group. We have a talk with them. So they are working on that, but still they have not able to do that. Basically, this is the extension of their last year method, last year work. So they have used a pin format. That is not as good. We have used physics format. So physics is involved at that. So both the work is just extension of the last year paper in physics of fluids. Yes.
One small question.
Yeah.
So we have you have given in perhaps slide number 10 regarding data.
10.
10.
Yes.
This is so. Is there any limitation of data for you have divided into 3 parts?
Yeah. This is basically given in the paper also. I have cited the paper.
Yes. Is there any limitation? That is any limit that for this less than this type of
Limit is
data?
infinite. That's what I'm telling. If I can go 0.05, if you can go below that, this is also good. Because as I told you, whenever you are training your architecture, it takes time. So our architecture takes 20 minutes. Usually, if you do it in let's say 16% data, it takes around 45 minutes, 60 minutes. If you take more than that, it will take let's say a few hours. So computational cost also have to take care of. So lot of things, computational cost, good reconstruction of the output, along with that, all these things. So you have to be very optimized. So optimization is very, very important. So those who are working in optimization, they also can think on that way because this is a multiple aspects are coming into picture. So that means that's why. So what I'm saying, the pin means it is you can say the combination of data as well as physics. How much less data you can use because physics is there, but ultimately you have to capture your parameters. So to do that, you need a combined effect of both. That means
Now you can compromise with data, but you cannot compromise with
physics.
the physics.
Exactly. That's why pin is so important. So
That's
good. Now actually those who are using artificial intelligence still they are trying to use physics informed neural network. So that is a good thing. Now in image processing also people are trying to use physics informed neural network so that computational cost will be less.
Yes.
And the main drawback of the artificial neural network is that it is only valid for a training data. If my training data is different, it will again a huge problem. So all these things are there. But
Sir, in that case, in stochastics, what we do, suppose you are generating the data, correct? No? You can generate, but that you have to ensure that that should be consistent and unbiased.
True. That's what I'm telling. No, I'm saying about the training. So when you are training a data, let's say for example, I'm giving an example. Okay, just we are working on that. So this is called the passive ranging. In defense, what happens nowadays? You cannot use radar. You know that what happens in Sindoor. So if you are using radar, it can be captured. I think we have already done right. Time is already done.
Just one question.
So that's why I want to just give the answer. Okay, so we cannot use radar because radar will give you some sort of yeah. So if we use data, if we use data, it is very difficult to use. So what we are using, what is the image? To object
some questions, but because we are
we can interact.
we can
yes, you are free to interact.
No
Because
compromise with lunch.
I'm also ready to learn many things from you people. Right?
Not at the cost of lunch. Okay,
Okay, thank you.
राजेंद्र जी अच्छा काम कर रहे हो.
जस्ट थोड़ी देर पहले खा के अब तो भूख भी नहीं है.
मैं तो लोगों को भूख लगी है. बहुत अच्छा काम कर रहे हैं.
Now, I would like to invite Dr. Mukesh sir to felicitate our today's speaker, Dr. Rajendra Kr.
Very good.
Now, I would like to invite Dr. Kapil sir to felicitate our today's chairperson, Dr. Mukesh sir. Thank you everyone. Now we will resume at 2:30 after the lunch break. You all can assemble at canteen for same. Thank you so much.
आपने मुझे बताया
सर वो कह रहे हैं कि आप जो आपके पास ये है यहाँ पे आपको यहाँ पे ये शेड्यूल का होगा ना तो आप इसको स्कैन करोगे ना तो इसमें आपका स्पेशल सेशन है ना आपका
राकेश का कवर
स्पेशल सेशन है ना आपका
आई हैव नो आइडिया अबाउट दैट मुझे कुछ बताया ही नहीं
सर फिर एक बार आप नीचे रजिस्ट्रेशन वहाँ पे एक बार पूछ लीजिए वो कंफर्म कर देंगे आपको